So, my dear students, let's go with this topic, that is multipath propagation and spreading, and it is a very important factor in cellular communication. So, myself, Dr. Govind Sen. So, we have discussed in previous classes how the cellular communication occurs and what are the architecture of any cellular communications. Now, in the design purpose, what are the major design factors that plays a very vital role in cellular wireless communications? So first one is the propagation effect. So propagation effect means the electromagnetic radiation or electromagnetic waves which propagates through free space and cellular communication or via cables. Okay, so this propagation or electromagnetic radiation may sometimes distracted by high-rise building or sometimes mountains or several indoor hazards, or that is the play that play as a dynamic and also unpredictable because it occurs suddenly. So this type of propagation effects may occur when the electromagnetic propagation takes place. Next one is the maximum transmit power level at the base station and the mobile unit. We know that electromagnetic radiation, that is in microwave power, is very harmful to human being or any living being. So this radiation of electromagnetic power should be constant to certain level so that it can't be affected with any it will not hamper the living beings. That's why your base station and the power level at the tower or base station and your mobile unit, means your mobiles, have constant power, that is maybe sometime in milliwatt. Okay, so this is very low to avoid the harmful effect of the radiation. Then typical height of mobile unit antenna. Okay, sometimes we have seen that in previous day Nokia phones have some monopole antenna that's come outside of the handset, and it is like a it was like some sort of lambda by 4 monopole antennas. But nowadays all the antennas in a mobile unit goes to inside of the design or inside of the mobile unit, because for miniaturization and for flexibility of the design, so that it will be more handful to use. So this typical height of the antenna plays a vital role, and where the microstrip patch antennas come, they are to get more miniaturized antennas. Then available height of base station antenna, you may sometimes see that there is a base station tower above a roof of a building, high rise building, or sometime above some mid rise building also. So this height of the base station antenna play a vital role. You have seen that towers are in so much height, but some are in moderate height. So this factor determines the size of individual cells, because uh, these factors plays the individual cell size, and this factor determines size of individual cells, means these radiation factors. Okay, the tower of antennas, the power that's divide that determine the how much space the base station can cover, so that the individual cell size should be controlled. Then model based on empirical data. Okay, so there is some empirical data based on the model can be based. So then apply this model to give an environment to develop guidelines of cell size. This model now applied to any environment, given environment in your cell area, so that the cell size could be monitored. And this model sometimes called Okumura IT by defined by Hata. Okay, this is the Japanese scientist who developed some models, and this is the details area on a Tokyo area. This is a typical example. Then is the fading. So fading is time variation of received signal. Okay, that is sometimes you may see in your mobile communication that sometimes the sound from the opposite side is hard to receive or very low in magnitude. Okay, and sometimes it is very high. So this variation, why this variation occurs? Because of the fading. So with time sometimes the amplitude becomes more, and with this receive less. And then is fading is that is caused by the change in transmission path. Sometimes the signal propagates to line of sight, that is in a straight line. Sometimes it is reflected from a building and goes to the destination, that is in a some bended path. That's why this is caused by change in transmission path. Next one is the atmospheric condition. So atmospheric condition, this is also play vital role as fading, because rain attenuation, we all know that because of the rain, if heavy rainfall occurs in a certain area, then there the communication also hampered. Because of the heavy rainfall, the fading will occur, and the signal quality or signal reception quality will be very bad. Next is the movement of mobile unit antenna. So movement of mobile unit antenna also a very means also a very important factor, because you may see in that previous days and the in the aeroplane, okay, there or in a high mobile units, it is very difficult to catch the signal at that unit. This is multipath propagation. So what is multipath propagation? Multipath propagation means the signal is propagating. Okay, someone want to communicate with some destination receiver, then signal is propagating. So this signal propagation will be in the some form of that is in a line of sight propagation, or maybe there is some high rise building, or there is some objects is there in the propagation path, line of sight propagation path. Then that signal will be reflected from that path, reflected from that object, and it will goes like in the multi path direction. So this is the reflection. So reflection is nothing but basically, if the surface is large relative to wavelength of the signal has frequency that is in the gigahertz or megahertz range, and corresponding to what will be the wavelength will be in the range of kilometers, or in the range of meters. Okay, millimeters. Sorry, the wavelength is, if it is in gigahertz, the wavelength would the millimeter. So if the surface, say if the object subsurface is large compared to that wavelength, then it will be reflected, may have phase shift from origin. So if the signal propagate to multipath propagation, then the phase shift will be from the original will be there, phase shift will be occur. And it may also, because phase shift means signal is some signal has in phase and some signal has out of phase. If both the signal are collide with each other, then sometimes it may cancel out, and sometimes it may increase also. Then diffraction. So diffraction means that is edge of impenetrable body that is large relative to wavelength. There is a edge of impenetrable body means see, suppose a concrete building that or sometimes that is a metal object. which is impenetrable. The wave cannot means cannot propagate through this object, then that is called as impenetrable. So from that edge of that impenetrable body, the diffraction of the signal will occur. Diffraction means it is diffracted or diffracted. Okay. So due to that, the signal may be received at the receiver if there is no line of sight to transmitter also. The signal is not in the line of sight of the transmitter. In case our mobile phones, we are not always in line of sight to the base station antenna, but we are able to receive the signal also because of the refraction. Okay. And when the it is line of sight, then there will be better communication, better signal strength. Okay. Then scattering. What is scattering? So scattering is obstacle size on order of wavelength, that is lamp post. So lamp post size, typical lamp post size is of the order of the wavelength of the signal, then this scattering will happen. So in that case, it was large enough to the wavelength. Here it is comparable to the wavelength. Then the scattering of the signal, it is scattered. Okay, scatter means ছড়িয়ে যাওয়া, so চারদিকে ছড়িয়ে যাবে. Okay, then scattering will happen. If line of sight diffracted a scattering signal not significant, then reflected signal may be not. Reflected signal will also take place, because if LOS diffraction and scatter signal not significant, then reflected signal will play important role. If there is no line of sight, diffraction, scattering are primary means of reception. So if the signal is not in the line of sight, not in straight line to the base station antenna, then the diffraction or scattering is the primary source of the signal reception. So we see this figure, then it will be clear what is reflection, what is diffraction, and what is scattering. Okay, so suppose this is your mobile unit, a movable car. Here mobile unit is this one. So signal is, in this case signal is this is buildings. Suppose these are the buildings, so it is going towards this way. Then signal may, reflection will happen here, because this is large enough to the wavelength, this building size. So reflection, then it is suppose the transmitter is in this case, transmitter or another sorry, base station is in this way, then the signal will reflected from this surface, again it will reflected from here and goes to this side. And what is scattering? So scattering, suppose there is a lamp post, this is comparable with the wavelength, then from the lamp post also, if there is, the signal may come also in this way. Signal is actually signal is omnidirectional antenna. If they are, then the signal will be in all the direction, that's why the signal comes from here to here, from here to here. Okay, a signal will come from here to here, and it will scatter at the lamp post, and it will goes to this way, the straight line. And what is diffraction, I have already told. So that is, if the signal wavelength is enough large enough, or the object is large enough compared to wavelength, then at the edge of the impenetrable body, that is, it is impenetrable body, so from the edge the diffraction is happening. So diffracted signal will goes like that. So there is three types of sources, that is, if there is no line of sight. So here line of sight is not occurring, so that's why three types: reflection, scattering, and diffraction. Then the effect of multipath propagation. So what is the effect? As in the previous figure, you have seen that in this three way the signal may be propagated. But what are the effect of this multipath propagation? So effect may be, signal may cancel out due to phase difference. Okay, as these three signal may combine at a certain point or converge at a certain point, and on that point, if it is seen that these three signal are out of phase with each other, okay, then suppose the two signals are out of phase with each other at a certain point, then what will happen? The signal strength will be become zero, or the signal that is signal will be cancelled out. So these two, these phase difference. and inter-symbol interference. It is a very important terms in case of multipath propagation or cellular communication. Inter-symbol interference or ISI. So what is the ISI? ISI is nothing but the sending narrow pulse at given frequency between fixed antenna and mobile unit. Okay, a narrow pulse is propagating. Narrow pulse will propagate from the fixed station antenna and mobile unit. So channel may deliver multiple copies. Channel can deliver multiple copies at the different times, and the delayed pulses act as noise, making recovery of bit information difficult. Okay, so the signal when it is goes through the channel, it may occurs that there will be delay in the channel, so that delayed pulse will give as noise to the corresponding sequences, so that the recovery of the original sequence will be difficult. So timing changes as the mobile unit moves, so time also change as the mobile unit is moving continuously. So it is harder to design signal processing to filter out the multipath effect. That's why it's very difficult to design the signal processing to filter out that multipath effects. So you can observe from the figure what is you will get clear about the ISI, inter-symbol interference. So suppose two pulses in time variant multipath system. This is time. So two pulses are transmitted. This is one transmitted pulse after certain instant, another transmitted pulse. Okay. So in the received signal, if you see that the received signal may be received from here, receive LOS pulse. This is at the line of sight of this transmitted pulse. Then this signal will come here, and it is also LOS part that is at the line of sight of that here. So these two signal are not received with this more or less like same amplitude. Okay, but what are the receive multiple pulses? So some signal maybe comes through the scattering, that's may this one, or some may be due to diffraction. Okay, so these are the signal due to scattered or diffracted from the multipath. So receive multipath pulses also due to some high-rise building or like that. So this signal may collide with each other and cause errors in the receiving end. Okay, that is the due to inter-symbol. This is called inter-symbol interference because two signals are interfering with each other. Okay, after this to the class is I am stopping this class, and in the next class we will see how different types of fading is there.